So today we are going to talk about deep feed-forward networks, and they are a kind of a neural network. A background on why these networks came into place, or why deep learning came into place, is in the recent years what has happened is that uh, we have now a whole lot more data and computational capacity to solve new problems, solve all the problems that we had. So, for example, the problem of face detection, right? Where you have a picture and you need to find out if there is a face in the picture. To solve it, there were so many methods before that were not based on deep learning, but now we have so much data in the sense that a lot of people have hand marked where the face is in the picture, and we have a whole lot of computational capacity with GPU computing coming into place, that we can use these new machine learning tools to gain better learners. So that's kind of the whole motto. And in a sense that if you would see, if I make a graph of the amount of data plus computational capacity that I have, and the accuracy that I can gain for a certain machine learning problem, all the previous classifiers would kind of saturate beyond the certain number of data slash computational capacity, but deep feed forward networks kind of keep going, right? And the reason for that is deep networks can approximate a huge variety of different classes of functions which other models couldn't do. Essentially, in deep learning or neural networks, what we are trying to do is that we are trying to approximate a function f. So this function could have many input parameters, right? So let's say I'm solving the problem of figuring out if a self-driving car needs to keep going on, or needs to take a left turn, need to take a right turn, or need to slow down its speed, or all the various decisions that it needs to make. And let's say there are 5 such decisions. So the output could be any of the numbers 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 0, 1, 2, 3, 4. And these inputs could all be all the data that you're generating, the camera that is coming in, all the other sensor that is coming into the car. This could be all of that input, right? So essentially, what we're trying to do in a whole lot of machine learning and neural networks is that we're trying to approximate a function. Earlier, we had some learners which could approximate linear functions, and that's just not going to solve all the problems, because the relationship between all these input variables and the output might not necessarily be explained in terms of a high dimensional planar surface. So we need to have more complex function. The second thing that we're going to talk about is what do these deep feed forward networks look like. So essentially what do they look like is that all these inputs, let's say there are n inputs, right? And these are fed into these functions, right? So this is some function of, let's say, a bunch of these inputs. Maybe this is another function of bunch of these inputs, and so on, right? Essentially it's going to be a function which will be a composite function of various smaller other functions. And similarly, these nodes could have certain outputs, and they could go into another set of, and so on. So let's say the output this guy had was h1, this guy had was h2. The number of nodes here need not necessarily be n. It could be more than n, it could be less than n, anything. And then there could be another layer here which is dependent on the inputs here, and so on. And then finally, there could be many such layers in between. And then finally, one output layer. So this is the kind of a structure of a deep network. We call these networks deep because we have added many layers, and to be able to train such a deep network has only been possible recently, that we have gotten more data and that we have gotten more computational capacity. Before that, there used to be neural networks which would have one layer and then one layer in between, which is called the hidden layer. These layers are called hidden layers because uh, all we care about is the input and the output. All the values in between are kind of hidden, and neural networks only used to have an input layer and then a hidden layer and then an output layer. And now that we have gone deep, we have many more layers, and the number of nodes in these layers are huge. Let's talk about feed forward. Um, so one curious thing that you would notice here is that the outputs of one layer go in as inputs to the next layer. The outputs of a particular layer is never input to a layer behind it. So in that sense, the data is always moving on in a forward direction. And there are networks, deep learning networks, which will have data moving in the reverse direction as well. And such networks are called recurrent networks. And each of these networks have usage in different kinds of problems in machine learning. And essentially, the art of learning all of this is to be able to know where works what. Like,
Um, well, so you talk about that before the other classifiers were only based in simple functions. So these networks are capable of adding like more complex functions or combining functions, or is that what you meant?
so let's imagine, it's a good question. Um, so if I'm right, the question is that what exactly do these networks do such that I'm capable of learning more complex functions, right?
Right.
So the first thing to know is that because there are so many hidden layers and so many ways in which I'm connecting them, the final output hugely varies in what I'm going to set these smaller functions to be, right? And because I have so many small functions to fine tune, I can use them to really make any function that I want to. Like an intuitive understanding of this can be gained from another smaller example that I can give you. Let's assume that there's this some random function that you want to approximate. I don't know what is the exact equation of this function, and it could be like some really vague equation, x cubed plus 4x to the power 4. I don't know what it is. So what I'm going to do is that I'm going to take smaller functions, smaller linear functions, and I'm going to say that this function is a composite of these small linear units. So I'm going to say that there is a linear function, linear line, which is this, right? And then there's a linear line, which is this. So what I've done is that I have broken it down into many linear